In this video, we want to solve this system of linear equations, 3 equations with 3 unknowns, x, y, z, using the TI-84 graphing calculator. There's many ways to do it manually. Substitution, you can use determinants, you can use certain matrix techniques. Well, here we want to use the graphing calculator used in several videos, and we want to do it basically using the home screen. No other special menus other than hitting several keys here to access numbers and so forth. And no special menus, because you can do this using other techniques on the graphing calculator. But in this case, we're going to use this technique. You can pause the video and see if you can do it on the calculator or do it manually, whatever. I'll come back and show you the method or the tip that I'm going to give you here. Okay, hope you tried it. Let me go. And this is what I'm going to enter to the calculator. Writing this out here just in case it goes off screen here and you can't see all the little steps I'm doing here. Basically what I'm going to do is I'm going to put a bracket here at the end and then enter 2 brackets, and in those 2 brackets, in between those 2 brackets, I'm going to put the coefficients of the variables for the first row. That would be the 1, the -2, and the 3. And then again, a set of brackets, and then inside the brackets, the coefficients of the variables, the 2, 1, and the 1, right there. And then the next one, finally the third row, coefficients of the variables, -3, 2, -2. And then I'm going to take that to the -1 power. That's what this is. It'll carry it, so this will be taken to -1 power. And then I'm going to multiply that. That's what this is, okay, in case you can't figure that out. That's times here. And then I'm going to put brackets again at the 2 ends. And then inside, all I'm going to do, inside the outer, the left bracket and the right bracket, I'm going to put the 7 in brackets, the 4 in brackets, and the -10 in brackets. And then I'm going to hit enter, and the calculator will give me the solution, if there is a unique solution. If it turns out that this system doesn't have a solution, the calculator will give me an error. Or if it turns out that it has an infinite number of solutions, then it'll still give me an error. And you'll have to try other approaches to get a formula that gives you those solutions. So let me begin here by, again, second, and the first bracket, and then another bracket, and then enter the components basically that I have there. And those are the coefficients of the variables for the first equation. So that's 1, and then a comma, and then a minus 2, and a comma, and then 3. And then I close the brackets. So second, close the brackets. Oops, wrong one. So close the bracket. Okay, so those are the components for that first row dealing with the coefficients. Then I go to the second equation. That'll be the second row you want, and that'll be again second, and then left bracket, and then enter that 2, comma, 1, comma, 1. Those again are the coefficients of the x, the y, and the z. 2, 1, and 1. And then I close this bracket. So second bracket here, close it. And see, it's going off screen. That's why I put it here so you could see it. And then I start another one, left bracket. I'm going to enter these coefficients of the variables: -3, 2, -2, -3, 2, and -2. So be -3, then a comma, 2, and a comma, then -2. And then I close the brackets. And then I close the brackets again. Okay, the end bracket again. So that'll be second. Okay, then I want to take that to the -1 power. So exponent here, and then -1. And then I'm going to multiply here, so I'm going to times. Then I'm going to enter this on the calculator. A bracket on the left and right, and then inside each component, in this case the components on the right, the 7, the 4, and the negative 10 will go there. 7, 4, negative 10. So again, be second, and then left bracket, and I enter the 7. 80 bracket. 7, and then I close the bracket. And then I enter the next one. Bracket. That will be 4. Close the bracket. Okay, start another set of brackets here. Enter the minus 10. Close the bracket. Left bracket or right bracket, as I say. And then I find I want to complete it. Okay, so if I hit enter, see what we get. Okay, so there are the what I entered. You can see the first row. If you look at that, as rows, is 1, negative 2, 3, 2, 1, 1, negative 3, 2, and negative 2, and then on the right, okay, I get 2, negative 1, 1. Well, it turns out that this is actually the solution to that system. X is equal to 2, negative 1 is equal to y, z is equal to 1. So again, x is equal to 2, y is equal to negative 1, and z is equal to 1. You can check this by plugging those in, but that is the solution. Now, question is, can you figure out why this works, why this technique works? And that's going to work. That's going to work for any system of linear equations: a 2x2, a 3x3, 4x4, 5x5. Okay, 5 equations, 5 variables. You can enter these all on the home screen. And notice I didn't access any other menus other than numbers here. Of course, the brackets, comma, and so forth. And you got the solution. And again, I want to point out that there's other ways you can get the solution by accessing the other menus, kind of like what I did on the matrix algebra video that I did previously. Okay. If you haven't figured that out, I do want to explain it to you in case you're not sure. Basically what I'm doing is I'm using a matrix equation. So this is the matrix equation right here. That A would represent the coefficients of the variables, which would be a 3x3 matrix. And basically the big capital X would represent the matrix of the variables. So that would be X, Y, Z. And over here we have the matrix of the constants. Seven, 4, and negative 10. Now, if I multiply the A is the coefficient matrix, or the matrix of the coefficients. So I can put, say, the 1 here, the negative 2 here, and the 3 here. And then the second row would be, again, the 2, 1, and 1. And the third row would be negative 3, 2, and negative 2. Now, if I do this multiplication right here, then manually the 1 would multiply the x, the minus 2 would multiply the y, and the 3 would multiply the z, and then you would add those using the rules for matrix multiplication, and I would get 1x minus 2y plus 3z equals to 7. If I do follow up with the other way, the second row, that'd be 2x plus y plus z is equal to 4. And then the next one, minus 3x plus 2y minus 2z equals to negative 10. Okay? So in this matrix equation, what we're doing is we're multiplying, what I did in the calculator is I'm actually multiplying this equation here by the inverse. So multiplying that out, and then so that the multiplication is defined, I need to multiply on the left side of this matrix B. Because remember, the multiplication is only defined if the number of columns in the first one is equal to the number of rows in the second matrix. So when I multiply A inverse and A, like you saw in the other video that I did, those are inverses, so I'm going to get the 3 by 3 identity. So this would be 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay, so if I multiply this out here, which again, this is the inverse of this. So I'm multiplying both sides of this, and that's what I did in the calculator, okay? Multiplying this side and this side by the inverse, okay, of this. But when you multiply something by its inverse, it gives you the identity. So this replaces that, and then I multiply that by x, y, z. Well, because this is the identity, all I'm going to get here is x, y, z. So on this side, I'm just going to get x, y, and z. And when I multiply this matrix by the inverse, I'm going to get those numbers that I got in the calculator. 2, 1. Or 2, negative 1. Negative 1. 1. So that's going to tell me that x is equal to 2. Y is equal to negative 1, and z is equal to 1. Solution set in an ordered triplet, this would be 2, negative 1, and 1. And that's why that little, which seemed like a little trick that I did here, this right here, this is what I did in the calculator. So this right here, what the calculator does here is calculate the inverse of the matrix of the coefficients. And obviously, right here, you're multiplying those constants on the right, this side. And then we got the 2 and negative 1. But because of the way the multiplication is defined, this just gives me that x is 2, y is negative 1, and z is equal to 1. Okay. That's why it works. I hope that makes sense. And thanks for watching. We'll see you next time.